And okay. So topology yung topic natin today. So sabi ko nga kahapon 'di ba topology sa cable. So hatiin natin siya kasi medyo mahaba-haba din siya ng kaunti. No, but the next week pag-usapan natin yung cable and its types pati yung paano mag doon sa RJ45 which is yung LAN cables natin. Okay? So dito muna tayo sa topology, then after this meron akong video na papalabas. Ayan, kung kita na. Okay? So let's go to the network topology. Kasi last time pinag-usapan natin 'di ba yung balikan natin yung lecture natin kahapon. So pinag-usapan natin is the basic hardware components, which is number one, yung mga network devices natin na ginagamit. At the same time, pinag-usapan din natin yung categories ng basic network, which is LAN, wireless LAN, MAN, and WAN. No? Lahat kasi ito ginagamit sa network. But today, we're going to the part of the network configuration topology. So sabi dito, network topologies have gone through many evolutions since the first network was introduced. After the development of new technologies and had been introduced, better efficient design has been introduced. Kumbaga, yung may mga topology type, for example, ring, bus, ito yung pinakaluma nating topology. And ngayon kasi more on hybrid, star, and mesh topology na yung ginagamit natin today. But we will explain it later on. So dito, sa ating by definition, what is network topology? It refers to how various nodes, devices, or connection on your network are physically or logically arranged in relation to each other. Kumbaga, ito yung magiging network design natin. Kasi 'di ba, yung gumagamit tayo ng cable, gumagamit tayo ng hub switches, magagamit 'yon sa mismong itong design natin, sa network design natin. Kung paano mako-connect yung devices, 'di ba? One devices to another device, no? Your network, sino na-copy na mic? Mute ko muna. Okay. So think of your network as a city and the topology is the roadmap. So kumbaga, paano ka makakapunta doon sa destination, 'di ba? Nagtatransmit ng data. Okay? Just as there are many ways to arrange and maintain a city, such as making sure avenues and boulevards can facilitate passage between parts of towns getting the most traffic. Okay? Yung mga sasakyan, ito yung magdadala ng data or information between one place to another. Okay? Kumbaga sa atin yan ngayon, yan yung bandwidth. Okay? Yung traffic na magdadala doon sa kasama mo. Okay? Magtatransmit ng data. There are several ways to arrange your network. Each has advantages and disadvantages depending on the needs of your company. So the arrangement can give you a greater degree of connectivity and security. Sabi ko nga 'di ba kahapon, kumbaga parang sa architectural design to kasi inaayos natin. Syempre may mga computers tayo, may mga printers tayo, other devices that can be connected into network. Okay? So syempre kailangan ng disenyo doon. Yung structure nila, kung paano yung setup, no? Yung haba ng cable, saan yung pwestuhan niya, ano ba yung gagamitin, LAN ba or MAN ba or depende. At the same time, ito ng topology na pag-uusapan na. Paano yung structure, okay, ng network mo. So meron tayong dalawa which is physical and logical. Bato na tayo dito. Okay? So the physical network topology, it refers to the actual connections such as wire, cables, yan yon. Okay? Mostly tangible. How the network is arranged. So maintenance and providing tasks required insight to the physical network. So mostly physical troubleshooting ang gagawin natin. So pagka nagka-problema sa cable, either papalitan mo o ayusin mo lang. Okay? Pag sinabi naman logical is more on the type of topology. Okay? So high level idea, including the nodes to connect each other in each ways. Okay? How data is transmitted through the network. Logical network topology includes any virtual or cloud resources. Or yung more on sa soft side ito. Okay? Effective network management and monitoring requires strong graphs of both physical and logical topology. Kailangan yun, magkasama pa rin yun. to make sure that your network is efficient and healthy. Okay, so let's discuss more on the network topology. So there are some we will discuss. So building a local area network or LAN. So diba, pag sinabi nating LAN, you are connecting devices within the particular area. For example, sinabi ko nga building. So first floor, ito yung connection. Sa second floor, ito yung connection kasi naka-LAN network lang siya. So within the local area. Kaya nga siya local area network. So can be man break of your business as you want to set the resilient, secure, and easy to maintain topology. Kasi syempre magtatransmit ka ng ano, iniisip natin kung paano mapapabilis. At the same time, mabilis din ma-troubleshoot, ma-configure, okay, mag-transmit ng data. These are several types of network that suitable to different purposes depending on overall network size of your objective. Okay? Let's go to the star topology. So makita nito, ito yung mga structure natin. Okay, star topology. So from the star. Pero syempre, meron siyang central hub para yung devices magko-connect doon sa hub and then si hub naman itatransmit niya kung saan ibibigay yung mismong data. Okay? So most common network topology laid out every node of the network is directly connected to one central hub, either hub to or switch. Okay? So it's connected to the central hub by a coaxial cable, twisted pair, or fiber optic, which is will be discussed in the following week. Acting as a server, ito yung magiging server nila, itong devices ito, kahit si printer kasama, the central nodes manages data transmission as information sent to any node of the network to pass through the central LAN of this destination. Okay? And functions as repeater to prevent data loss. For example, kasi may dalawa. So may broadcast and unicast. Okay? Pag broadcast, of course, syempre kung saan siya magsisend, so lahat sila kailangan ng ng MAC address. So yun yung magiging unique address mo para doon tatransmit yung data. So makaka-access ka sa mismong network niya. For example, network ko tapos network ni Clint. Okay? So may MAC address. So pagpunta ko doon sa network, so makaka-access ako doon, pwede ako makapag-send sa kanya ng data. Okay? At the same time, dito, yung magpiprint, syempre, for example, nag-print ako, so nakakonect yung printer dito, so magta-transmit siya sa print para makapag-send siya ng task na ma-print yung mismong PC na ito. At the same time, sila din pwede rin. Of course, naka-inline yan. Okay? So advantages yan is convenient manage your entire network for the single location. So sa cabling kasi medyo mura lang, no, hindi naman komplikado na masyadong maraming linya, no, but each node is definitely connected to the central hub. So ibig sabihin lahat sila independently connected. Should one go down, the rest of the network will continue to function. For example, nasira ito, nagkaroon ng problema ito. So siya lang yung may problema, hindi madadamay yung ibang network. Okay? Pero ang disadvantage niyan, pag ito ang nawala, wala silang network lahat. Kasi ito yung central hub or central server nila. So sabi dito, devices can be added, removed, and modified without taking the entire network offline. So ibig sabihin, pwede pa mag-connect ng isa o mag-connect pa ng another one para makakonect sila lahat. Okay? So wala namang mangyayari doon, of course. The physical side, the structure star topology uses relatively little cabling so to fully connect to the network. So yun ang maganda naman doon, which allow to both straightforward setup, management over time as the network expands or contracts. Okay? So disadvantage, yung una na sabi ko, if the central hub shuts down, so pag either nasira or naka-off, hindi kayo makakonect sa isa't isa. Okay? So overall bandwidth performance of the network is also limited by the central node's configuration and technical specification. So kumbaga pag nag-send din, for example, sabay-sabay, of course, may bandwidth tayo, yung traffic, no? Maghihintay tayo kung gaano katagal yung transmission, okay, ng data from one device to another device. Next natin is bus topologies. Isa din sa mga old to, no? Old form of topology. Ito naman, yung structure naman nito ay backbone. Usually uses coaxial cable. Okay? So parang nakadikit silang lahat doon and then magko-connect. Okay? Through LAN cable. So LAN cable then sa mga coaxial. So may mga certain cable sila na magko-connect sa bawat isa. Topology of bus orients all devices to the network along single cable running in single direction. So isang linya lang siya that end to the network to the other. Which is why it's sometimes called a line topology or backbone. Okay? Parang tayo, di ba, sa spinal cord natin, lahat ng nerves sa connect. Okay? So ganon, kung ano yung gagawin nito, magre-respond sa kabila. Okay? So data flow on the network also follows the route of the cable moving in one direction. Okay? So kapag ka nag-send naman ito ng data, ito for example, so kailangan din ng MAC address para makapag-send siya dito. Okay? So advantages, mura lang siya, efficiente din naman siya, cost effective. It's good for the smaller network kasi simple lang naman yung ano niya yung structure. Pwede siya i-connect via coaxial, single coaxial or RJ45 which is yung LAN. If needed, more nodes can be easily added to the network by joining additional cable. Syempre, pagka ganun na, no, mahahabaan mo yung linya nyo. Okay? Pero syempre, ang disadvantage ito, syempre, pag nagkaroon ng failure, lahat kayo failure. Okay? Lalo na sa connection. Kasi isang linya lang kayo Sabi dito, because bus topology is single cable to transmit data, they're somewhat vulnerable. If the cable experiences a failure, the whole network goes down. For example, nagkaroon ng problema dito. So automatically, lahat na yan, sira na yan. Kasi sabi ko nga kanina, isang kable lang kayo. Diba? For example, ningat-ngat lang ng daga yun, so sira agad yon. Okay? And of course, kung maggagawa ka rin of course, it's time consuming. Okay? So, inexpensive to restore. It can be less an issue with the smaller network. So, bus topology are best suited for the small network. For example, dito lang sa bahay, okay? Or may sarili kang, sabihin natin lang, parang simpleng opisina. So, for example, 6 kayo. You can use your bus topology for the simple connection. No? Pero, hindi na to applicable sa mga malalakihan. Kasi syempre, they are using hybrid or star or usually 3. Usually, yun yung ginagamit nila. Okay? So, yan yung disadvantage. Bus topologies are better suited. Yeah, tama lang. Better suited for small networks because there's only much a bandwidth. Kasi, pagka madami na nakakonect, ang problema naman yung network traffic, yung bandwidth. Magbabatuhan kayo lahat ng data So, yan disadvantage pa. So, it is half duplex. It means it can be sent into opposite direction at the same time. Okay? So next naman natin ito ring. Okay, so doon lang tayo sa ring topology. So ito, nag-interconnect lang to dito, then dito hanggang sa dulo. So kung pwede ka pa magdagdag na another, so another cabling ulit yun. Okay? So it's arranged or the single that data travel through the ring network either on one direction. So in one direction lang siya pag ganon. Okay? So pros, okay? Advantages is since each device is only connected to the ones on other side, when data is transmitted, the packets also travel along the circle. So paikot. Moving each of the intermediate nodes until they arrive their destination. Okay, for example, nandito siya. So dadaan mo na siya dito para makapunta doon. Ganun yung sistema ng ring topology. Okay? If a large number is arranged in ring topology, repeaters can be used. So may another device that can mas ma-ensure natin yung transmission ng data, hindi siya mawala, which is yung repeaters. So only one station of the network is permitted to send data at a time. So kumbaga isang beses lang. Ibig sabihin yung device, okay, siya, for example ito, so makakapag-transmit siya, okay, so kumbaga in every task one at a time. So which reduce the risk of collisions and make ring topology efficient to transmit the data without errors. Okay? So mura din siya, cost effective. Yung installation niya madali lang din kasi intricate point-to-point connectivity. So make it easy to identify issues, madali din siyang i-troubleshoot. So pwede ka pa mag-add ng another device within that ring topology. Okay? So ano naman, ang disadvantage naman nito is vulnerable to failure without proper network management. So pagka mali yung network management, so it's possible na mag-fail. So since the flow of data transmission moves directionally between nodes and along its string paikot, if one node goes down, it can take the entire network on it. Okay, that's why it's imperative to each of the nodes and we monitor it kept in good health. Okay, so if you're vigilant attentive to node performance, your network is be still taken down by the transmission line, a failure. So yun yung mostly ng ano natin. So the entire network was taken offline, okay, to reconfigure add. So kung mag-add kayo ng network. Okay, it is not end of the world. Scheduling diamond network can be convenient and costly. Next natin is ito, ring topology is more on hierarchy ang dating niya. So get its name how the central node functions sort of the trunk of the network with nodes extending outward to the branch-like fashion. So ito yung central hub, then may another extension siya which is secondary hub niya para yung ito makikita nitong lahat. Okay? So either usually star ang topology niyan. Okay? Or bus topology. Okay? Sabi dito, each node in the star topology is connected to the central hub. Okay? Lahat ito, yung hub din to. Okay? Connected to the central hub, connected linearly in other nodes. So two nodes can only share mutual connection because tree topology structure is both extremely flexible, scalable. So ito, mga malalakihang networks na to. Hindi tulad na na-discuss ko kanina na ring topology, bus topology. Okay? So pang maliitan lang siya. Okay? Pros ng tree topology, combining of star and bus topology. Okay? It can be allowed for easy addition of nodes and network expansion. So masasabi, for example, ito ay, kasi ito kasi it's possible, dito na sa downlines. It's possible na, ano siya, bus lang siya, backbone lang siya, or pwede ka rin star. No? Kasi meron ka namang secondary hub. Okay? So, saan tayo? Troubleshoot errors, it's also straightforward. Madali lang din troubleshoot. Yan, individually access for the performance issues. Ang cons lang, as with the star topology, entire network depends on the health of the root nodes of the tree topology. Okay? If the central hub fails, syempre, lahat sila disconnected. Through connectivity within, not in between, branches still will remain. So, for example, ito, nag-off to, ito lang yung off. Pero kung ang central hub ay nag-off, lahat kayo off. Ganun lang siya. Okay? Next naman natin is mesh. Ito na yung medyo magulo, pero ano to, more on point-to-point connection. So for example, ito, 1, 2, 3, 6. So yung 6, nakakonect ka rin dito sa 5. Okay? So limang networks din yan. For example, itong laptop ko, nakakonect din ako kay Anjo, kay Clint, kay Carlo, kay Ken, saka kay Mark. So lahat ako nakakonect sa network. Makikita ko siya dito sa network, sa may file explorer. Okay? So mostly ginagawa to sa mga malalaking companies. So it's an intricate and elaborate structure point to point where nodes are interconnected. So mesh network can be full or partial mesh. Okay? So mesh topologies are mostly interconnected. It's only 2 or 3 connections. Okay? Webline structure mesh topologies offers 2 different methods, routing and flooding. So yan yung ano niya. So advantages, it's more reliable and stable. Okay? So the complex degree of connectivity between nodes makes the network resistant to failure. For instance, no single device going down can bring the network offline. Kasi marami nga siya nakakonect din. So disadvantage, so labor extensive, time consuming at the same time mahal kasi ang daming kable. So pero syempre yung topology na to may mga central hubs din yan saka there's mga switches and hubs. Okay? So yun yung labor intensive. Okay? So as we other topology, cost of cabling, add fast, stay networks require a lot of cabling is understatement. So yun lang naman yung disadvantage. Pero advantage yan, mabilis ang transmission sa yung troubleshooting. And lastly is the hybrid topology. So combine two or more topology structure, whether a three example, merong bus saka star. Ito namang hybrid, ito ay naka-star topology and then naka-ring topology. So hybrid are most commonly found in larger companies where individual departments are personalized network topologies adapted to suit their needs of network usage. So may mga kumbaga certain sila hubs, okay, magko-connect topology, one topology and another topology. So same as with the tree topology. Okay? Advantage niya, hybrid structure is degree of flexibility. There are few limitation of network structure. Okay? Disadvantage naman niya comes with all disadvantages. As network grows in complexity, it does so does experience and know-how required to part of admins to keep everything functioning optimally. So may mga servers na to actually. And kailangan pagkaingatang maigi so para lahat, kumbaga yung network connection natin healthy and yung transmission ng data maayos. So there's all monetary cost considered when creating a hybrid. So mostly, sabi nga dito, mga malalaking companies na to, mga 3 hybrid sila yon. No, pero yung kung for example, for smaller networks lang kayo, you can use ring topology, bus and star topology. Okay? So ito papakita akong video about the network topology type. So dalawa siya.
Hey guys, this is DG. Today we will learn what is network topology, its types and how they differ from one another. So let's start. Network topology is how computers connect or relate to one another in a computer network. It is of two types, physical topology and logical topology, where physical topology describes the way computers connect with the help of cables. Logical topology describes the way data flows from one computer to another within a computer network. The most common computer network used to interconnect physically distributed computers is local area network, which has three main topologies: star topology, bus topology, and ring topology. Others are mesh topology and hybrid topology. Please note the data in the network layer is in the form of IP packets. IP packets are packed into frames in the data link layer. Physical layer then transmits the frames into the transmission media. So, in a computer network, data moves from one computer to another in the form of frames. The same term will be used in the further discussion. Starting with bus topology. In a bus topology, computers connect to a shared central cable called bus with taps and drop lines. Shared means that all connected computers use the same cable for data frame transmission. Taps are the connectors and drop lines are the cables running in between computers and the bus. In this topology, if a computer sends data frames to a second computer, all other computers connected to the same central cable also receive the frame. That is, other computers can hear what the first computer is saying. However, only the target computer accepts it. Others reject the frame by checking the destination MAC address in the received frame. Suppose you are distributing prices as per the results of a competition. You ask Ram to come on the stage for his reward. So only Ram will go and collect the prize. Same is in the case of bus topology. Only that computer accepts the frame to whom it is addressed to. Since bus topology requires less cabling, so it is easy to install and less expensive to implement as compared to other topologies. However, with the increase in the length of central cable and the increase in the count of taps, the strength of signal decreases. So, only a limited number of computers can be connected in bus topology. In this topology, all computers depend on the central cable for data frame transmission. So, if the central cable fails, it paralyzes the whole network. That is, bus topology has a very little fault tolerance. Here, a security risk also exists because all computers can hear what other computers are saying on the shared media. In a bus topology, only one computer can transmit data at a time. So, while one computer is sending a file to a printer, other computers have to wait. If other computers too start sending data at the same time, it will collide and corrupt the whole data. In such a case, data should be retransmitted. Therefore, if more computers connect to the same central cable, the network will become slower and also increase the chances of data collisions. It is one of the reasons why bus topology is rarely used in modern computer networks. The collision can be avoided by using an access control protocol. For example, carrier sense multiple access with collision detection. Example of bus topology is Ethernet LAN. Next is star topology. In star topology, computers connect to a central device, a switch or a hub with point-to-point communication links. Point-to-point connection means that there is a dedicated link or cable between the two devices. Other devices cannot use it. In this topology, if one computer wants to send some data frame to another computer, it is first routed to the central device. The central device then either broadcasts or unicast the received data frame towards the destination computer based on the type of the central device used. Broadcast means the transmission of data to all connected devices, while unicast means transmission of data to the target device only. If the central device is a hub, it broadcasts the received frame to all the connected computers. That is, a hub is a multi-port repeater. The frame has a destination MAC address, which is unique to every computer present in a network. So only target computer accepts the frame, others reject it. Since a hub broadcasts the received frame, so it increases unnecessary data traffic in the network. To overcome this limitation, a switch is used as a central device. Every computer has a unique MAC address. A switch stores the MAC address of the devices connected to its ports. It is called a switch table. Since data frame it receives has a destination MAC address and the switch knows that the device with MAC address MAC2 is connected to port P2, so the switch forwards the received data frame to port P2 only. Hence, instead of broadcasting, the switch unicasts the frame. Suppose your computer is connected to a printer with a star topology network. Now you click on print on your computer to print a file. The file is sent to the central device. If the central device is a hub, the file is forwarded to all connected computers. However, only printer accepts it. On the other hand, if the central device is a switch, the file is sent to printer only, that is unicast. Moreover, when the computer is busy in sending a file to the printer, computer A and B can also communicate with each other without affecting the computer-printer link. That is, switched connection allows simultaneous communication. On the other hand, a hub allows only one device to communicate at a time. Please note, if the destination MAC address in the frame is Ethernet broadcast address, then the switch also broadcasts the received frame. In star topology, only one input-output port and one cable is needed for each device to connect to several devices. It makes it less expensive than the mesh topology. It is also easy to reconfigure because we can add or remove devices simply by connecting or disconnecting one cable. If one cable connecting to the central device fails, only one communication link goes down and not the entire network. So, star topology has a good fault tolerance. Fault detection is also easy because we only need to locate a computer which is not receiving data. However, if the central device goes down, the whole network is paralyzed. One more limitation in star topology is the number of computers in a network is limited by the number of input-output ports in the central device. Example of star topology is high-speed LAN. Now, ring topology. In a ring topology, each computer connects to two adjacent computers to form a ring. Data transmitted by one computer moves from one computer to another in a circular fashion to reach its final destination. The advantages of ring topology are easy installation and less cabling. In this topology, data moves in one direction. It reduces the chances of data packet collisions. The ring topology is relatively easy to troubleshoot because we only need to locate a computer who stops receiving data from its upstream neighbor. However, as each data frame has to pass all computers between the source and destination, it makes data transmission slower than the star topology. Since all computers connect to form a closed loop, one fault paralyzes the whole network. It is difficult to reconfigure because we need to break the ring to add or remove the computers. Due to this reason, the physical ring topology is rarely used. Instead, logical ring topology is used. Example of ring topology is token ring. Token ring does not use a physical ring topology. Instead, it uses physical star and logical ring topology in which data moves in a circular fashion. Token ring uses a token passing protocol where a frame called token keeps on circulating on the ring. If one computer has data frames to transmit, it holds the token and transmits the frame. Once the transmission is done, the token is released into the network. A token ring network is deterministic, meaning each connected computer is given access for transmission at fixed time intervals. Therefore, a network can have one physical topology and an entirely different logical topology at the same time. Mesh topology. In a fully connected mesh topology, each device has a point-to-point link to every device in a network. Therefore, if the number of devices in a network is 4, then the number of links or cables each device have is 4 minus 1, that is 3. Now, we have 4 devices. Therefore, total number of links or cables 4 devices have is 4 into 4 minus 1, that is 12. Note that these are simplex links. In simplex links, data can move in one direction only. So, one link is used for sending data and the other is used to receive data from the adjacent computer. Duplex links are the ones where data can move in both directions. Therefore, we can replace 2 simplex links with one duplex link. Hence, the total number of duplex links in the mesh topology is 4 into 4 minus 1 by 2, that is 6. In general, if there are n devices, the total number of simplex links are n into n minus 1. The total number of duplex links are n into n minus 1 by 2. And the total number of input-output ports in each device are n minus 1. So, if the total number of computers to be connected is 10, then the total number of duplex links will be 45, and each device should have 9 input-output ports, which would be difficult to manage and also increase the cost. However, the dedicated point-to-point link eliminates traffic problems, which are encountered if a link is shared among several devices. The dedicated point-to-point link maintains privacy and security of the messages shared between two devices because other computers cannot hear what computer A is saying to computer B. If one link fails, it does not affect the whole network, that is good fault tolerance. Since each device is connected to every device, so installation is difficult. Multiple input-output ports and a large number of cables increase the cost and make it expensive. More cables in mesh topology consume large space too. Example of mesh topology is the connection between regional telephone offices. All topologies are interconnected to form a hybrid topology. Now, every topology has its merits and demerits. So, while choosing a physical topology for a network, we should always consider its cost, ease of installation, ease of maintenance, and cable fault tolerance. If you have learned something from this video, then please like this video. Share this video so that more people can learn. Subscribe to TechTerms if you want to learn more and turn the notification.
What are network topologies? So that's what we're going to talk about in this video. Now, a topology is the layout of how a network communicates with different devices. And there are a couple of different categories of topologies. There's wired and wireless. So we're first going to talk about the most common wired topologies. And the most common wired topology that's used is the star topology. Now, in a star topology, all computers are connected to a central wiring point, such as a hub or a switch. All data on a star network passes through this central point before continuing to its destination. Now, one of the major benefits of this topology is that if one computer failed or if there was a break in the cable, the other computers would not be affected because each computer has their own cable connection. However, a disadvantage of the star topology is that if the central hub or switch fails, then all the computers on that central point would be affected. And this is called a single point of failure. If this happens, the entire network goes down. Another type of topology is called ring. The ring topology is a type of network configuration where each computer is connected to each other in the shape of a closed loop or ring. So every computer on this ring has exactly two neighbors for communication purposes. Each data packet is sent around the ring until it reaches its final destination. Now, this kind of topology is very old and is rarely used today. Now, the advantage of a ring topology is that they are easy to install and easy to troubleshoot. However, the disadvantage would be that if just one of these computers goes down, or if there was a single break in the cable, then all data flow would be disrupted. And the next one is the bus topology. The bus topology is very old technology and, like the ring topology, it's not used today that much. This is the kind of network setup where each of the computers and network devices are connected to a single cable or backbone. And this backbone is a coaxial cable. The computers connect to this cable using special connectors called BNC, which are also known as T connectors. One of the advantages of the bus topology is that it is also fairly cheap and easy to implement. However, a disadvantage of the bus topology is that it requires that the cable be terminated at both ends using terminators. In order for this setup to remain operational, there must not be any open connections, including the ends that attach to the computers. So if a computer is removed or if the terminators are loose or missing, then the cable would be open and then data would bounce back. And this bounce is known as signal reflection. And if this happens, data flow would be disrupted. And there is also the mesh topology. Now, in a mesh topology, each computer on the network is connected to every other computer on the network. So by having so many connections, it handles failure very well. In this illustration, there are 4 computers with 3 connections on each computer, which makes a total of 12 connections for this network. Now, the advantage of a mesh topology is that it creates a high redundancy level, because if one or more connections fail, the computers would still be able to communicate with each other. However, because of the amount of cabling and network cards that have to be used, mesh topologies can be expensive, so they are rarely used on local area networks or LANs. They are mainly used on wide area networks like the Internet. In fact, the Internet is a good example of a mesh topology, because the Internet is made up of numerous routers all over the world that are connected to each other to route data to their intended destination. So even if a few routers go down, the data will get rerouted using a different path to ultimately reach their destination. So the internet is very redundant because it's using a mesh topology. So now we're going to talk about wireless topologies. So let's start with the infrastructure wireless topology. Now this topology uses a combination of wired and wireless devices. Now this is very similar to a star topology, where you have wired devices such as these computers here physically connected to a switch. And you also have a wireless access point that's also connected by a cable to the same switch. The wireless access point is here so that wireless devices such as laptops, tablets, cell phones, etc. can connect wirelessly to the network. So the wireless access point acts like a bridge between the wireless network and the wired network. Now the infrastructure topology is not limited to a single wireless access point. In fact, you can have multiple wireless access points if you want. It just depends on the needs of the network. And the next wireless topology is ad hoc. Ad hoc is a very simple wireless topology, and it's simple because it doesn't rely on any infrastructure such as cables, routers, servers, or wireless access points. All the devices in an ad hoc network wirelessly connect to other devices in a simple peer-to-peer network. They directly connect to each other without using a centralized device, such as a Wi-Fi router or access point. And because they directly access each other without a server or router in between, each device is responsible for its own security and permissions. Ad hocs are useful for setting up a quick wireless network on the fly where devices can share data without the need of an existing wireless network. And the last wireless topology is called a wireless mesh. Wireless mesh topologies are similar to wired mesh topologies, where devices are interconnected with each other, but with the exception that they are wirelessly interconnected. So for example, let's say you wanted to deploy multiple wireless access points all throughout a building so that wireless devices that are in different areas are able to access the internet. So normally you would have a modem that brings in the internet to the building. And then you would also have a switch that's connected to the modem. And then you would connect each wireless access point with a cable to the switch. So by doing it this way, this requires extra cabling, and it would also require extra time running the cables through the building. So this is more expensive and more time consuming. Now a wireless mesh topology would be similar to this setup, but without the need of these extra cables. In a wireless mesh, each wireless access point will talk to other wireless access points to create a seamless internet connection for wireless devices to connect to. So if this laptop over here wanted to access the internet, it would connect to the nearest wireless access point, and then this access point would relay the connection to the next access point, and then to the next one, and then eventually find its way back to the modem. So no matter which access point that you're connected to, you will still have internet access because all the access points are in constant communication with each other and the modem. And even if one or more access points were to fail, it wouldn't matter because the other access points will reroute the data. So a wireless mesh topology is very redundant because the internet connection is spread out over many wireless access points.
Okay. So that's our topic for today, which is network topology. So in additional yung mga videos natin about mga wireless topologies natin. So next week we'll be talking about yung cables kasama din yung OSI layers kasi is part of the network yon. Okay? Do you have some questions?